Good evening friends, I hope you are following the thermodynamic video lectures. So, the last class what we discussed means the definition for the Cp, that is the molar specific heat capacity of the gas at constant pressure, and the previous class what we discussed means molar specific heat capacity of the gas at constant value. Today our goal is to learn about the relation between the Cp and Cv, that is nothing but the Mayer's relation. So, this will be very simple formula, and this may ask the in competitive exam also. Based on this formula we are going to derive some of the other formulas also. Let me go to the derivation for the what is the relation between the Cp and Cv. So, from the first law of thermodynamic we are going to derive this one. What is the first law of thermodynamic we are going? First law of thermodynamic. First law of thermodynamics. What is saying? The amount of heat supplied to the system is equal to the change in internal energy of the system and external work done, dW. dQ is equal to du plus dW we will get it. Now, as we know the definition of the Cp, if the process is done at constant pressure is equal to the amount of heat supplied to the system is equal to, what is the formula? NCP delta T. This formula is known. Where is the formula? If P is a constant, P is the constant. With help of this Cp definition, TQ is equal to NCP delta T is there. If we are performing the process at constant volume, du is equal to, what is the formula we are having? So, the amount of change in internal energy is equal to NCV delta T is there. So, when if volume is equal to constant, these are the definition, this is the formulas which are derived from the definitions of the Cp and Cv. Now, one more formula is there. One more formula is there for work done, external work done by the gas is equal to, so we are having PdV. This is the formula we are having. So, if the system is having, the substance is taking the ideal gas, if the substance is an ideal gas, then work done PdV is equal to, we are going to is equal to PdV is question mark. So, we are taking PV is equal to nRT formula we are taking, then P the pressure is constant into dV is equal to nR into delta T, because of N is the number of moles, R is the ideal gas constant, the variable parameter is only the change in temperature. Just I did the partial definition of the above equation with by putting the pressure is constant. Now, let me take, this is the equation number 3. Now, the substituting the values of the, this is equal to W, all in the first law of thermodynamic, dq is equal to du plus dw. So, this is the formula we are stepping. dq is equal to ncp delta t is equal to ncv delta t is equal plus nr delta t. This is the formula we are getting. So, in this all equation the common terms are, n is the common terms, I am cancelling this one. So, dt, the change in temperature also is the common term. Then what is the formula we are getting? Cp is equal to Cv plus R. So, then Cp minus Cv is equal to R. This is the relation between the Cp and Cv, or this is the relation for Mayer's formula. This is the Mayer's relation. Mayer's relation, very important equation from this one. Now, with help of this Mayer's relation we are going to use some of the other derivation of the other equation. Now, let me go to the other equation. Cp minus Cv is equal to capital R we are getting, then Cp is equal to Cv plus R we are getting. I already told you in the Cp definition, if you have any doubts means to go through the definition of the Cp content. So, the what is the formula we are having? Cp in terms of degree of freedom, Cp in terms of degree of freedom is equal to Fr by 2. So, Cv value in terms of degree of freedom This is the formula for the CV value in terms of degree of freedom. Just I am substituting this CV value in the above equation. Cp is equal to Fr divided by 2 plus R is there. If you take the R is the common term, then R is equal to 1 plus F divided by 2. This is the formula we are getting. Now we already evaluate the values of the CV values for monoatomic gas and diatomic gas and polyatomic gas. In the same manner, we are going to get the values for the Cp values also for mono, di and polyatomic gas. Now before dealing this one, let me recall the formula once again. Cp in terms of degree of freedom, where R into 1 plus F divided by 2. So now we are going to write the values of the Cp values for monoatomic gas. What is the monoatomic gas? Monoatomic gas degree of freedom F is equal to 3. Then from this one, Cp value is equal to, just substitute in this equation, then R into 1 plus 3 by 2. By evaluating this one, then 5R by 2. This is the formula. This is the value for the Cp for monoatomic gas. Now diatomic gas. For diatomic gas, the F value, degree of freedom F value is equal to 5 value we are getting. Then Cp is equal to R into 1 plus 5 by 2, that is equal to then 7R by 2. This is the value for the diatomic gas. Now triatomic gas or polyatomic gas for linear system is equal to triatomic or polyatomic. The gas is at linear gases. This is the degree of freedom F is equal to 5 only we will get. Then Cp value is equal to same like this, we will get the 7R by 2. Then triatomic or polyatomic, but the non-linear atom, triatomic or polyatomic gas at non-linear gas, the degree of freedom is equal to 6 we will get. Then Cp is equal to R into 1 plus 6 divided by 2, that is equal to 4R. We will get the value for this 4R. So if this is the table for this one, Cp and Cv, you can frame the Cp and Cv in the same table, in a single table for the remembering this one. Now let me write the table. This is the monoatomic gas, diatomic gas, it is the polyatomic gas. Poly is the linear gas, or polyatomic non-linear gas, polyatomic non-linear gas, then Cp, I am taking Cv. What is the formula? For the Cv? Fr by 2. This is the formula we are having. Now Cp value is what is having? R into 1 plus F divided by 2. This is the formula we are having. Then frame a table which can easily understand what is the values of the Cp and Cv value. Just now we evaluated these values are 4R. These values are 7R by 2, this value is the 7R by 2, this value is the 5R by 2. Now I am giving the homework for you. Just fill the values of the monoatomic gas with help of this one. Now just I am substituting the degree of freedom is equal to F is equal to 3, F is equal to 5, F is equal to 5, F is equal to 6. Now just use this formula and fill the above equation for Cv value also. You can easily remember for the Cp and Cv values in terms of degree of freedom and ideal gas constant R value. So I hope you are following the videos lectures thoroughly. Thank you for listening. Thank you.